Hello, my name is Samuel. I am the founder and CEO of ExeQuantum. ExeQuantum is a cybersecurity startup that specializes in post-quantum security, allowing companies to adopt post-quantum cryptography seamlessly and smoothly as we are migrating to a post-quantum cryptography world. Today we have Dr. Dimitrios from Swinburne University. Dr. Dimitrios, why don't you introduce yourself a bit before we proceed to our first topic?
Thank you, Sam. Lovely to be here with you. So I'm Dr. Dimitrios Salampasis. I'm the FinTech Capability Lead for Swinburne University. I'm also Senior Lecturer of Emerging Tech and FinTech. I do research, teaching, and industry engagement and global thought leadership in the areas of emerging tech, in financial services, public sector, and business in general. And I've got a very, very special interest in relation to quantum technologies.
Very impressive.
Well, thank you.
So for our first topic today, we'll be talking about quantum computing and how they are currently described as a revolution in the making. How do you envision its impact on industries beyond the traditional tech sector, and which unexpected area might see the most profound changes?
Well, as you probably know, and you're more familiar with this topic, quantum computing is bringing a completely new way of thinking about computation. It's not a new computer; it's a completely new way of thinking around ways that computation will revolutionize business. And I think the way it's done, it's because of the fact that it is based on quantum physics. So basically, conceptualizing differently the way that we think about computers. I think there are a lot of areas, particularly around optimization, simulation, cryptography is a big part of it as well, that is going to change the way not only we understand about problems, but the way of approaching problems that currently can't be solved with classical computers. And I think there is a lot of use cases across different verticals. Think about drugs, health, think about traffic optimization, think about weather predictions and simulation models in insurance. And also bear in mind that all of these are part of more of a globalized environment where complexity is accelerating, it's becoming way more complicated. So we live in a very complicated world where problems are becoming way more complicated, data is becoming more abundant, therefore we need the proper computational power to ensure we have the ability to manage all that properly.
I completely agree. I mean, think about how classical computers have changed the world, that have affected every single aspect of our lives, and that's somewhat of an understatement. So this is a completely new type of computer. It's going to be the next, basically the same revolution that the computer has done, but more complicated, more high scale, which exactly like you said, because of how complicated our world is becoming. Like think about the supply chains so much. I mean, even like regular computers have trouble like working out all that data. It's very heavy. There would be it's basically the next step for humanity. There are some, of course, downsides, such as our current cryptography being too simple for quantum computers, but it's definitely a revolution one way or another.
But maybe it will be interesting also maybe to give us a bit of a very, let's say, basic overview of why quantum computing is very different compared to classical computers. Where does this difference come from?
Sure. So basically, classical computers use logic at its core, true, false. And that's pretty much it uses a lot of other different mathematical, but at the core it uses that. Quantum physics is a bit different. In quantum computers, utilizing quantum physics is quite different. It's not true or false. It's true, false together, and everything in between. So much more data in those little qubits compared to a regular computer. Now, of course, the challenge is how do we get, since it's everything at once and until we observe it, then it collapses. How do we actually manage to grab the right state? But if the more we crack that, the more, again, we can talk about potentially millions of times faster. I mean, we kind of found it out with Shor's algorithm to have current cryptography, bringing the time of calculation from literally millions of years to minutes. That's such an improvement. Imagine it being applied to everywhere else.
And of course, what is also critical is the fact that because the logic is not around R is 0 or 1, it's this constant multiple states at the same time, there is a very sensitive balance between, superposition, decoherence, entanglement, that all of these things need to happen at the same time. And I think this is one of the main problems, how to actually succeed in creating this kind of delicate balance for quantum computers to actually be able to operate properly.
And then like the stability, of course, I mean, superposition is not that useful for us. What is useful is like with the data that it comes out as a result. And the issue is how do we then keep that data instead of making it go back to superposition where we lose that data. So yes, there's definitely a lot of challenges. Potentially some of those challenges will never be solved. We don't know. There are a lot of stuff we don't know, but it's definitely, like you mentioned, very delicate. That's the main challenge. It's extremely delicate. Like classical computers, their bits nowadays are so tiny that even some like single photons coming from the sun can disrupt them, causing planes to like go suddenly much lower altitude. Because there's been a story, I don't remember exactly, but I think like the bits were controlling how high the plane should be. A single photon flipped one of the bits to like a much lower number, so the plane just actually like descended. Thankfully it didn't crash, but think about then going even smaller, how difficult it is to keep the qubits stable, if it's hard to keep even classical bits
Absolutely.
stable.
And I think what is also important is the fact that you mentioned about that there's still a lot of research going on in the space, and also what is critical to remember is currently we don't really have a commercializable quantum computer. We've got different types of capabilities, but I think what is also critical to remember is that there is a bit of a philosophical debate around, is it important to reach quantum advancement or quantum supremacy? And I think there is a bit of a different schools of thoughts here from different organizations that want to achieve either or.
Yes, because it's a good point. Like a lot of people really believe that quantum computers will never become scalable per se. They will remain as like they will kind of replace maybe supercomputers. So like the biggest companies, the governments, the ones who need the specialized computational power will be utilizing quantum computers, but it will never become you will never get a quantum laptop, which I'm not sure is even, I think even as we speak it's all changing, because actually looking at this article, SeedQ is building real quantum computers for AI, not just small processors. The company has launched ExeQuantum, the world's first multi-qubit mobile quantum processor which operates at room temperature.
Interesting.
That happened in September 16th.
Okay.
So as we speak, those breakthroughs are happening and are rapidly increasing. I see them in more and more frequent.
So R&D is escalating basically. It's accelerating a lot.
Exactly.
Okay, that's very interesting. Now, just maybe for our audience to have a bit of an understanding, is there a fundamental difference between a quantum computer and a supercomputer?
Yes, I would reckon so. It's a different type of computer. A supercomputer is basically a classical computer, make it bigger.
Right.
Of course, it's not always just making it bigger, it's making it like have more bits that operate more efficiently, have less disruptions, better temperature control, etc. But it's essentially bigger computer. A quantum computer is just the bits itself, the processors, they're all acting on a different type of physics. Instead of logic and other types of mathematical operations, it's using quantum physics. So it could potentially become, don't quote me on this, but like it could potentially become much stronger than a supercomputer, even if you have like much less qubits than a supercomputer has. Because as I mentioned, even the largest supercomputers cannot break RSA, for example.
Right.
But it's not going to take this amount of qubits as we actually originally thought. We originally thought there needs to be like millions of qubits, but according to some sources, we need much less than that, really.
Right. And in many discussions I've been having with industry, they're all asking the same questions. How do we actually access that? Does it mean we need to have quantum computing capabilities in-house, or can we access it via cloud, or will there be like specific providers that they need to access that? And I think that creates a bit also of anxiety around, will we be left behind, or do we all have access to this kind of capabilities? Because imagine the ones with access what kind of competitive advantage they may have compared to others. So I think cloud would be a potential way to access this kind of capabilities.
I think it's like today we have cloud, we have AWS. I don't need to build my own servers. Like my computer can be a server, it can hold some amount of data, it can hold the data I need for myself, but it can't hold millions of users. So instead I rent out the server that AWS holds somewhere. It's not actually on the cloud, it's just a bunch of servers. So I think it would be the same with quantum computers. Maybe you could get access to a small scale quantum computers like the one I just read, which could do some basic things or basic quantum things, still much stronger than a classical computer. But in order to do even bigger calculation, the one that will potentially bring us to Mars, you will potentially need a bigger quantum computer. And individuals who want to do those big calculations will need to connect to a cloud.
Absolutely, absolutely. And you know, business is also really scared because one of the key common denominators around the discussion around quantum computing is the notion of breaking current cryptography. So everybody's talking about pre-quantum versus post-quantum cryptography. I was also reading somewhere that there is a lot of currently discussions on the fact that protecting data, because currently hackers can actually steal data but then decrypt them later. So there is also a time lag around the ethics of protecting specific data. So why do we have this kind of conversation around pre-quantum versus post-quantum cryptography?
As you mentioned, harvest now, decrypt later. It's already a massive problem. Like hackers all around the world are already taking in a massive amount of data that they can't read now, but it's definitely going to stay relevant. Most people don't change their passport within a few years. Most people don't change even their credit card. It's massive amount of extremely important information. And I know that like individually, most people will not have a quantum computer in their hand for, I don't know, possibly a decade, maybe even more. But I think that the first one to actually utilize a quantum computer to hack for like malicious purposes will not be an individual, but a terrorist organization or a government.
So is it about hacking or about decrypting?
Well, to some degree they are kind of
Interrelated.
Decrypting something you shouldn't be able to is kind of hacking. But I reckon that's basically at the core, being able to decrypt the data. So if we narrow it down from hacking to decrypting, that would be more clear. And you can see different approaches taken by different countries to it. Like you could compare China versus the US. It's kind of interesting. China is going full in on quantum key distribution, which is at the core quantum computer powered cryptography. Theoretically unhackable, practically speaking it's a lot more complicated than that. The US took a different approach, looking into post-quantum cryptography using classical computers, using lattice-based, multivariable, hash-based algorithms, with lattice-based being the most promising looking ones. I mean, they're the ones that have been standardized in addition to Falcon Plus.
Well, actually, I was talking to a conference a few months ago and about the public sector, and one of the key messages that I delivered in my presentation was around national security. That is going to have massive implications in relation to all this data, all this, sensitive information that could be available to anyone in the future if lack of provisions wouldn't happen. And I think this is where the discussion around post-quantum cryptography is taking place. And if I recall correctly, recently there was an announcement about some standards, right?
Yes. So as I mentioned, the different approaches, China's gone all QKD, quantum key distribution. The US thinks it's quite tricky to build quantum key distribution. You need a quantum computer for it. They're trying, post-quantum cryptography is a lot more accessible, a lot more scalable, so that's the approach the US took. They started this competition in the middle 2010s, where a bunch of companies, cryptographers, have sent in their algorithms for standardization. Over the years, NIST has been, which is a US agency for cybersecurity, has been testing and standardizing those algorithms, developing them and working on them. In 2023, they have done their final round, selecting Crystal Skyber, Crystal Dilithium, and Falcon Plus as candidates for finalization. Just like around a month ago, in August 13th, 2024, they have finally selected those algorithms to be adopted. I think it goes well with their own act that they passed in 2022, the Quantum Preparedness Act, that's
Right.
what it's called.
Right.
Now they and the public and the private sector have algorithms that they can adopt for their own quantum security. It's not, of course, straightforward. There's a lot of overhaul involving, a lot of changes, which is one of the things we're trying to do at ExeQuantum. We're trying to make it as seamless and smooth as possible because we need to do it as soon as possible. But overall, we have actually, we say we have a light at the end of the tunnel, as they say.
But one of the questions I'm getting always from industry that I'm talking to is, I don't think it's only about complication and making things more seamless, but I think it's also about accessibility, making sure that everyone has access to this kind of capabilities. So, and also, majority of industry basically doesn't even have a clue. They don't even, think about the fact that this is happening. So there is a need for preparedness, and I think you were very spot on this. Readiness is very critical, and at the same time, though, and that's a fair point, provided by industry and also by the public sector, is that since this capability, this technology is not yet commercializable, what's the business case to invest in it? So is there a message here around how do we actually ensure that there is the development of a quantum culture within business?
Yes, raising awareness is extremely important. Pushing the urgency is also extremely important, which is one of the things we're trying to do here. Of course, accessibility is also one of the things we're trying to do at ExeQuantum, but that's something for another discussion. Yes, it's quite difficult to get people proactive on regular cybersecurity, let alone quantum cybersecurity. So I think the more conversations we have, the more we get people to read those government articles that are all around, like the Australian government, the American government, all governments are basically saying we need to switch as soon as possible. But like you said, most people don't read it. We need to get people to read it. We need to get people to understand this is real, this is coming. You need to act now. And of course, it's like you said yourself, providing awareness is just step one. We need to provide a solution. Providing easy solutions, affordable solutions, accessible solutions is definitely one of the keys.
And definitely, it was so fascinating when I was preparing for that keynote. I was looking at many jurisdictions around the globe are pouring a lot of money. So, and including Australia, some of them have a specific, quantum computing roadmap. Underlying the key visions, the challenges, and of course the key challenges behind the tech part is also the talent, which is actually missing, the cost in terms of actually developing a business case. But needless to say, the doors which are open around, the social side, the ethical side, all these ESG governance side, which we're still not even aware, because I think all these actually will be developed and will be realized in the same journey as the technology evolves as well. Also, something that's quite fascinating is all of these technologies, they can't survive standalone. There has to be some convergence, like with AI, with blockchain, with 5G, because the common foundation of all that is data. So I'm sure part of the development in quantum technology is interrelations with all the other emerging techs, which are also evolving at the same time. So as you can see, there are some sort of parallel journeys on how the convergence actually occurs.
Yes, I think I completely agree. I think they will all be complementing each other.
Mm-hmm.
AI might be needed for some help with quantum, how to improve quantum. I'm not sure myself. I'm not an AI expert. Maybe it can fit into some error correction things. Quantum will definitely be able to empower AI. In fact, that might be exactly what we need, the upgrade we need to achieve AGI, for example.
Mm-hmm.
Maybe classical computers don't possess the computational prowess that an AGI would need.
Mm-hmm.
Same with, say, blockchain or other industries. We do know that quantum computers are going to be able to break blockchain.
Yes.
And
crypto and all that. Yes.
Yes, because the blockchain and crypto are relying on RSA for the digital signatures, which quantum computer, as we've discussed, can break, which means it's kind of an existential threat. However, if we could, of course, we can switch to post-quantum digital signatures. which is also again something we provide. We have quantum safe digital signatures specifically for crypto or for other type of spoofing protection. However, I think a quantum powered blockchain or crypto would definitely be something interesting to look at.
Absolutely. Or imagine a combination between generative AI and quantum, bringing this notion of massive data management and all this processing is going to be fascinating to see, but at the same time so scary because it opens up doors that can't be controlled. So, and I mean, what I also say to my students and also to everybody that I talk to, because all these technologies and also including quantum, they are going to be part of our lives. So they're already part of our lives. I think there is also a need to redefine the social contract of humanity and machines because. And it's not, something which is more, sitting at the, blurry future. It's here. So, I mean, I was featured in the news yesterday about a major bank here in Australia. I'm not sure if I can tell the name. That they're actually planning to replace approximately 2,400 staff they've got in their call centers with ChatGPT. So imagine all these implications, and imagine if quantum comes in with this kind of massive processing capability, how this is going to change a lot. So I think the existential threat is there, but maybe let's think it from a more of a positive approach around coexistence and also what kind of new language and vocabulary we have to start using to create this kind of coexistence.
Yes, I think personally...
Too much philosophy now, but I think it's part of the discussion actually.
Of course, nothing wrong with a bit of philosophy. I think we have a lot of plans on how to replace workforce, not many plans of what to do with the workforce that gets replaced. But the thing is, it's not like it's impossible to have a plan. The thing with technology is that it can be a very powerful democratization tool. I mean, with smartphones now, everyone has access to like maps, to calculators that can really help them with their daily tasks. Same with computers and like cloud. And now with AI, on one hand, it can replace people. On the other hand, the same people can utilize AI to actually help themselves become better as well. So then they can become more competitive. However, there's not nearly enough action in that area. I think that if we focus more on that area, like with quantum, for example, like if we can democratize quantum and teach people how to utilize quantum computers to become, to help themselves, to help in their daily tasks, help with their work, most importantly, we can really enact a much more positive change.
Right. And in any case, I mean, for future reference, when it comes, to what's next in business, in society, in public sector and the likes, I think awareness is the key. And also understanding and appreciating the fact that even though this is a technology that will probably materialize or be hopefully operational within the next 10 to 12 years, readiness and preparedness is very critical because it's, as you can appreciate, technology is accelerating so fast. I mean, who would have thought ChatGPT would be in our lives 2 or 3 years ago, but you can see now what's happening. So, and there might be breakthroughs in quantum computing technology way faster than we all think or anticipate. So I think organizations, government, society, they really need to embrace all these emerging techs, including quantum, of course, and see this as the next step of evolution or humanity ends technology coevolution.
Yes. I completely agree. Like I think AI was kind of a lesson. Nobody was talking about it. It was only for nerds, and then suddenly it's everywhere. I suspect it's going to be the same as quantum. Everyone is saying, "Oh, it will never happen." Suddenly it's everywhere. Like AIs have been told, "Oh, there will never be." I remember even after ChatGPT came out, I heard people saying, "Well, it will never create videos." Now it's creating videos.
Absolutely.
Same with quantum. See, people are saying it will never be available for individuals.
Yeah.
It might be.
And videos for both good and bad purposes. Yeah.
So what's next? Like you said, readiness, preparedness, proactiveness, awareness. all those keywords are.
And also understanding that whatever we learn now, it's going to be redundant very soon because things change so quickly and so fast.
Yes, I mean it's much faster than like educational institution can catch up.
Absolutely, absolutely. Well, that's great conversation. Thanks for doing this, and it's really, really nice to see also passion, research, and I think this is needed. Like this is needed from businesses, this is needed from the government, this is needed from daily people, and of course from a higher education point of view, we need to have this kind of translation of technology for our daily lives and business in particular.
I agree. Together, like when we work together to raise awareness, to help people become more prepared, the more we do it, the better. Like the more positive
Absolutely.
we can hopefully make this technology.
Absolutely.
Thank you very much.
Thank you
for your time.
Thank you so much for the invitation.
Of course. Thank you very much, and thank you for listening.